My name is Aaron Binns. I work at the Internet Archive. There's my email address. Please don't give it to a spammer, but feel free to email me if you have a question after this talk. Like I said, I work at the Internet Archive. I've been there since the start of 2008, so almost 4 years now. Senior software engineer, and yes, I am the guy at the office that wears the jacket and the tie, even though I'm a developer. It's sort of my way of being anti-establishment. Since everyone I know wears a t-shirt and jeans, I have to be the other guy that dresses up. But in addition to full text search, I get to work on a lot of other cool stuff for the archive, dealing with our big data. A lot of it is done in Hadoop. We're huge into Hadoop at the archive. I was going to put some Hadoop slides in here, and I didn't think there would be much of a Hadoop discussion at this conference, and then of course this morning's keynote made me realize, oh darn. But anyway, I'll touch upon maybe Hadoop a little bit along the way and how we use it, especially with regards to our full text search indexing. And at the archive, pretty much everything we do is open source. We're all about open and free and people using our stuff. And so all the source code that I'm going to talk about today is available on my GitHub. So feel free to jot this down, and at any later point you can bring up the source code and file bugs and embarrass me and ask me crazy questions about it. So the Internet Archive, for people that don't know this organization, our motto is universal access to all knowledge, which is a very noble goal, but also a very challenging goal as well. We were founded in 1996 for this purpose. We are a nonprofit organization in the United States that's also called a 501c3 nonprofit organization. We're actually a digital library in the state of California. So if you go to California and look at the list of all the libraries, we are actually one of them, but we are entirely digital. We're located in San Francisco. And the big kicker is we have about 7+ petabytes of publicly accessible digital materials, which is a lot of stuff. The majority of that, about half of it, I would say, is our web archive, which I will describe in a moment. But we also have scanned books. There's over 3 million scanned books that you can access for free, just like going to a library, and you can just get on your computer and get the PDF and read it. There's like 1 million music and video, and there's over 1 million hours of television that we've archived over the years that you can watch. So being a library, the purpose of all this is like the purpose of a library. It's to provide this information for the common good of humanity and to preserve it and make it accessible over time. And when I say over time, that's a theme that will keep coming up through this talk, having to do with our web archives. So I asked if people know the Internet Archive. How many other people maybe have heard of this thing called the Wayback Machine? It's also one of our big projects. It's probably the thing we're best known for. It's web.archive.org, also waybackmachine.org will take you there. And going back to 1996 until about today, there's approximately 165 billion archived web pages. Now that's the text, the images, the CSS, the JavaScript, the Flash, the MPEG video, the audio, all these formats, and that's sort of in that number encompasses everything, everything we've ever archived from the web. And it's a lot of stuff. And it's easy to forget what the web was like years ago, so the Wayback Machine is a really great way to revisit how the web was. And let me show you a little snapshot here. So who also remembers this thing called the Jakarta project from years ago? And way back when, as we like to say at the archive, let's set the Wayback Machine for November 20th, 2001. So this is a URL on the jakartaapache.org website, November 20th, 2001, that announced this really cool project called Lucene, which I think some people here have heard of. And this is a static screenshot of the Wayback Machine, but if on your computer you were to go to web.archive.org, what we're actually doing is replaying the archived content. So this is the HTML page, all the links, you can click on the links, you see the images, everything. So we're trying to replay the web as it was that we archived on that date. And hopefully you're already starting to think like, oh man, if we're indexing this for full text search, that's quite a challenge. And it is, and that's some of what I'll talk about. But I'm not going to talk specifically about the Wayback Machine. What I'm actually going to talk about is a service we provide called Archive It. And what it is a subscription web archiving service. So the idea is that we provide sort of a mini Internet Archive as a subscription service. So for organizations that cannot afford to do their own web archiving because they're too small or they don't have the technical competency, they can subscribe to our service and perform their web archiving tasks through this service. So what the customer does, the end user basically, is select the websites they want to crawl, select the frequency and sort of the depth, how many links to crawl across, and then we take care of the rest. We have, the automated software system that does the crawling and the harvesting. It's put into a mini Wayback Machine for each customer, so they have their own little Wayback Machine of their stuff that they're archiving. And then it's also indexed for full text search. And like I said, the customers tend to be organizations that have a need for web archiving but can't afford to do it themselves because of either cost or they don't have the IT staff. So we have a lot of public, state, and university libraries in the United States, local governments, museums, other non-governmental organizations. And we've actually got a large breadth of customers, not just from the US, but from all over the world. But one of the key concepts, and I'll kind of finish with the sales pitch part sort of at the start and get into some of the technical stuff. There are two really key concepts in Archive It and also web archiving. And these aren't, this isn't rocket science, but these are the key things how we've arranged our data. One is the concept of a collection. And if people are familiar with libraries, a collection is just a collection of stuff. It's the set of books that's about a particular topic or is a particular theme. Similarly, we have a collection of web documents. So it's not only the web documents, but also the configuration. So when someone says, hey, I want to create my web archive, they might create a collection around a particular event that's happening, like the Occupy Wall Street that's happening right now, or the Arab Spring, those ongoing events. Or it might be more focused on a traditional topic of humanities, like there's one of our customers has a topic about Shakespearean theater, and so they're keeping track of all the Shakespearean theater companies that are out in the world and tracking them on their websites. But just the collection is that you put in, here are the URLs I want to crawl, here's the frequency, here's the depth, and then what you get is the associated set of web documents that go into Wayback Machine and full text search. And I've been using the word document, and really when I use the word document, what I mean is sort of a text URL. So a web page that's HTML or PDF or Office, something that's kind of text. We don't think about the images, the CSS, the JavaScript, because we're not really doing like source code search, that kind of thing. We're really concerned about what sort of people want to come to a library and search and find, that sort of thing. So we're really talking about the text part of the web when I talk about documents. So here's a screenshot of one of our Archive It collections, and I'll use this to kind of explain some of these tricky concepts having to do with full text search of web archives. You can see this is, okay, it's okay to read maybe, at least the big parts, but it's North Carolina State's government website archive. And so you have the North Carolina State Archives and Library, they're archiving their own state's stuff. And like many archives and state libraries, there's actually a mandate from the government to say, hey, you need to preserve and make accessible all of our own state publications. That used to be all really fine and say up until the 1990s when all those publications were on paper and they could just put it in the library and you would go to the library and get it. Well, now all the publications are on the web. And so the libraries are kind of having a panic attack figuring out, oh my gosh, now what do we do to preserve these publications on the web and then also make them accessible? So they're using Archive It to help provide that feature and capability. But you can see here a few cases where these are websites that are actually selected by a human being. So there's people at the North Carolina State Library that select the websites themselves. They also enter in some of the metadata having to do with the description and the title and that sort of thing. But they can pick entire websites to archive, or they can pick just specific URLs to archive as well. But once they've set up that collection, all the harvesting happens behind the scenes. They just push the go button, fire and forget, and we handle the rest. Now the next slide I want to get into really is starting to touch upon one of the complexities of dealing with web archival search. So this is a Wayback page for one of the URLs in that collection. So at the very top, and it's kind of in gray, it might be hard to read, it's called Healthy Carolinians. So it's all about health of people living in North Carolina, and it's a website. And you can see that we've crawled it many, many times over the years. So starting in 2001 up until 2011. And the crawl frequency has varied over time, and that's because the librarian at the North Carolina Library decided, this year we want to crawl the site more, and then maybe after 2010 they decided, oh, maybe quarterly is fine. But you can see on this slide that we get a lot of captures. And this is just the one URL. This is just the homepage. This isn't the entire site. This is just the one homepage. We have, I don't know, like over 100 captures. And then the other thing that's useful to note here, because it comes back later, is you can see these little dots. I think they're really asterisks, but look like dots. Those are times where when we crawled the page, it was actually different from the previous time. And so all the ones without dots are ones where we crawled it again, but it hadn't changed. Because as people know the web, some parts change frequently, some parts stick around for seemingly ever. So if you look in kind of the 2005 column, February 3rd, we have a new version, and then the 5th, the 12th, the 8th of March, the next 5 or 6 have no dot, which means we kept going back, and the site was exactly the same over and over again. So in the Wayback Machine, we can kind of show people this global view from a calendar perspective. Okay, for this one URL, here's all the captures and here's all the versions. You pick what you want and we'll play it for you. And to give you an example, I took the July 27, 2002 version and the September 15, 2001 version, did a screenshot of each, and you can see, the page changed quite a bit over time, which isn't surprising. 2002 page kind of looks like a 2002 web page a little bit. It's not that fancy. And then, of course, in 2011, they probably hired a graphics designer. And they're like, oh, yeah, man, look at our website now. But the point is, in Archive at Service, we're archiving all this content over time, and we're making it available not only through this interface, where you have to go in and select a page, but also through full-text search. So hopefully, by giving you guys some ideas about the way this data is structured, you might already starting to think about, well, how does this impact search? Certainly one challenge with search is that if people come here expecting it to be like web search, they already have a pretty high expectation of what it's supposed to do, because everyone knows Google and Bing and Yahoo, and they just expect, okay, that's what web search means, and your service better be like that. So there's kind of an expectation challenge right away. And the other is dealing with this time element. So not only do we have to deal with sort of what people expect out of a web search if they're searching the current web, but also somehow communicating to them how archival web search, when you add the time dimension, is a little bit different, and how to engage with that. This is a quick snapshot of looking for the term healthy Carolinians. Fortunately, the ranking works, so healthy Carolinians is the top hit. But then you can see that there's some other hits from other websites having to do with health of eating more fruits and vegetables and diabetes risks, that sort of thing. So you get kind of a familiar-ish web search experience. But in this example, what you're only seeing is one hit from Healthy Carolinians, that one website. But you might be thinking, well, which version is it? Is it that one? Is it that one from 2002, or is it the one from 2011? And which one should it be? Like, should the newer one be ranked higher than the older one? Or maybe the older one should be ranked higher than the newer one? So these are all sort of open questions a little bit. And on this slide, what you can see is we're actually getting some diversity of results as well. As I pointed out, we're getting one hit from Healthy Carolinians, and then we're getting some other hits from things talking about eating fruits and vegetables and diabetes and those sort of things. Now, if we didn't have diversity, this is what our search might look like, which might be like what people experienced in web search circa 1997, back in the bad old days, where you might get like a dozen hits from the same website and you think, man, this is terrible. Like, give me some diversity, give me some different things. So, but this kind of shows you the example of the time dimension, where you might say, okay, for this one URL, I actually want to see all the hits over time and how things have changed. So let me get to some of the actual technical specific stuff. Some of the challenges that we've encountered, I've touched upon a few of them. I'll get into some more details here a little bit. And then some of the solutions that we've at least tried to come up with and sort of where we're at. So one, of course, has to do with scale. In the title of my presentation, there's already over 1 billion pages. So I'll talk about that. The fact that, archival web search is not exactly the same as web search. It's kind of familiar, but a little bit different. Anyone that's dealt with web data before knows the headache of dealing with data formats on the web. I mean, especially HTML. HTML stinks. Like nowadays, everyone's like, yeah, HTML5, it's finally good and I can make sense of it. Well, we have HTML going back to 1996, and I'll tell you, it's nasty stuff. And of course, there's like PDF and Office, and again, those formats have changed over time. So we kind of have to carry all of our baggage with us that I'm sure a lot of people would be happy to forget. As I mentioned, we have customers all over the globe, so we have multi-language kind of challenges, the same ones that any sort of web search organization would face, English and European languages, Far East Asian languages, everything. And then the last two, which are like kind of really the two that give me all this gray hair, is the diversity and then the time aspect. You kind of think of those as like two different axes a little bit. You might have diversity of content where you want to get results from a lot of different sources, but then you also have the time aspect as well, and present that in an interface that people feel comfortable with, coming with their expectation that it's just like web search, but a little different because there's time. So scale. At the archive, for the archive at service, I mentioned earlier the Wayback Machine for everything we have is like 165 billion URLs. Archive it is much smaller, but it's still fairly sizable. For all of our customers total, there's 2,272 collections. So as I mentioned before, these collections are the set of websites to crawl and then the documents that are crawled for those websites. And they, each collection just accumulates over time because these crawls, they happen over and over again. Some crawls are done quarterly, some are done monthly, some are weekly, daily. So you just have this like constant growth of stuff. And they vary in size tremendously. Some of the collections are quite large, like the largest one is 33 million documents. 24 of them are over 10 million documents, 250 of them are over 1 million documents. If you take everything all together and add it all up, which is something that I do because I want to make sure the number is always going up because we never delete anything, so it should never go down. But as of last night around midnight, there was 1,375,000,000 unique documents in our full text search index. So these are actually documents in the full text search index. And the whole thing on disk, if you take all the shards and you add it all together, it's about 4.5 terabytes. And we are using stored fields in compressed form, so it might be bigger than you might expect if you didn't think we were storing the fields, but we are, so that's sort of the size of things. And like I said, each day it's sort of like, I don't know, just one of those unstoppable forces. There's about 30 to 40 simultaneous crawls, harvests happening per day, crawling different websites for different partners, different collections, pulling in about 150 gigabytes of data. So that's all the data, the HTML plus the images and media. But in terms of talking about the text documents again, we're getting about 1.3 million new or unique versions of documents. They're either new URLs we have not seen before or new versions of URLs, like that example I gave before where the page changed over time. So it's the same URL, but it's entirely different page contents. So what we do is when we're seeing pages that we've actually seen before but have not changed, we're still updating the record of the time that we visited them because we want to provide some sort of date search aspect. So if we keep visiting the same page week after week after week and it doesn't change, we keep incrementing sort of that time range over which that page has remained the same. And then suddenly it changes, oop, it's a new version, and then that continues on. So again, that's a key challenge in the full text search aspect. A quick thumbnail sketch of the architecture. I'm not very good with doing diagrams in OpenOffice, so I just kind of wrote the text. We do offline indexing, so we basically have an index building farm, so to speak, and an index serving cluster. Basically 10 dedicated indexing machines that are just running 24/7. It's all just kind of a bunch of scripts that we've written that as data comes in from the crawls, we build the indexes and update the indexes. So we've basically, and let me step back for a second and reiterate a point earlier, and actually it's further down the page. We basically have a system where we've taken each collection and built a Lucene index for it. So it's a very simple model to manage and keep track of over time. So whenever a new collection is created, new documents come in, they go in that collection, we put those into a standalone Lucene index. So for every collection that we have, which is 2,272, we have those many Lucene indexes. So we have this cluster of 10 machines running 24/7, pulling new documents in, seeing new visitation dates on documents that haven't changed, and updating the indexes accordingly. Our hardware is pretty shoddy by almost anyone's modern standards. I think during the Hadoop conference this morning, or the Hadoop talk, they talked about a lot of Hadoop clusters are built on whatever old machinery happened to be lying around. At the archive, we're a small organization, and we try to make every penny count, so we're pushing all of our machinery sort of beyond its normal, I would say, expected vendor life cycle. But we're actually in the process of upgrading this entire machinery later this year to sort of more up-to-date 2011 standards with quad-core or dual CPU and a reasonable amount of RAM and everything else. But this is what we're working with today. So we have 10 machines that are constantly updating building indexes in an offline fashion. Then they're migrated over, basically rsynced over into the live search servers in the wee hours of the morning, of which there are 11 machines that we've set up in sort of a federated situation where there's one master and sort of 10 slaves, and the master farms out the queries to all the slaves. They send back whatever results they have, and things are aggregated. And I'll give some more detail about that in a little bit. But things are about 10%. There's 10 machines for indexing, 10 slaves, so everyone gets about 10%. Now, I want to reiterate a little bit about what I said before about diversity, because this is like a really, really key aspect of not only web search, but also archival web search. And I apologize if the text is kind of hard to read. I did a search last night on a well-known web search service, which will remain nameless, but you can probably guess this one, for Lucene. And what we can see is that the first 3 results all come from lucene.apache.org. The first one is actually a link right into the Lucene docs. Second one is the homepage, and the third one is, well, actually it's the incubator site. And then there's this nice little Spanish link that says to the effect of, if you want to see more results from this website, click here and I'll expand it. But then it moves on and says, okay, I've given you enough from one website, let's give you some diversity. Let's give you a few hits from somebody else. So you get a few from Wikipedia, and then another link, let's show me more, and then you get Dos Ideas and something about being addicted to work and using Lucene. But that's kind of the point of diversity, giving you a sample of results from different sources, because who wants to see, if I type Lucene and the first 10 pages of results were all lucene.org, I'd be pretty upset. It's like, hey, give me some variety here, give me some diversity. So again, I'm kind of bringing back this slide that I had earlier, which says, in our case, we had the same problem, diversity, but not only diversity of websites, but also diversity in time. And here again is that same slide kind of showing you that if we turn off the diversity feature in our search, then what you get is not only a lot of hits from the same website, in this case, Healthy Carolinians, but you're getting multiple hits of the same URL throughout time. The first one being September 15th, 2011. The next one was January, November. So it kind of goes backwards in time, because we've decided for our users, it's best to give them the freshest content at the top for the same URL as opposed to the oldest one. So how many people here have kind of had to deal with the diversity issue in any of their deployments or anything? Yeah. It's something that, like I said, has caused me great stress in terms of implementing it for our collections. As applied to web documents, the best way to describe it is, hey man, give me the best 1 to 2 hits from a site and move on. And that's kind of what I showed you in those examples. In Lucene, there's a contrib package for grouping, which came out fairly recently. I think maybe 1 or 2 minor revisions ago. I actually haven't used it myself yet, but I've read through the code and it looks fairly promising. And then of course Solr has a feature called field collapsing, which is also very similar, where you say for a field, collapse the results down and give me maybe only the best 1 or 2. And I think Solr 3.3 also has like groups as well. So I apologize, I'm not really an expert in these things. These are sort of things I'm tracking as like potential solutions for us to migrate to, because we don't want to be on a custom solution forever. But these are sort of what's out there. And people that have dealt with these before, I'd love to chat with you over lunch or sometime during a break and hear some of your experiences and swap ideas. But one of the key aspects for us, in my point of view, is kind of the cost, not only in terms of performance per query, but what machinery, what sort of hardware do you really need for a certain size to make this stuff work? Because as I said in an earlier slide, we're running with some fairly ancient hardware, and if we're trying to plan for our next major hardware revision happening at the start of 2012, any data I can get from people to help ballpark what we need would be tremendously helpful. But then the last sort of bullet here, which is what I'll talk about, is the custom solution that we've come up with to deal with the diversity aspect and the time aspect. And I'll mention here, again, the time is kind of a wrap up. Part of it is also, part of the challenge of time is just user experience and understanding. If people just come to our site and don't think about it as a web archive and just think of it, oh, it's like the web and tick, 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 oh man, why isn't this like Google or Bing or Yahoo? This is terrible, I'm leaving. We kind of have to educate them a little bit. And like the slide that I showed with all the capture dates of that one URL over 10 years, until people see that, there's kind of this notion of, oh wait, and then they see it and think, oh yeah, this is actually kind of complicated. Like if I'm doing a search, how do I navigate through time? So it's a bit of just educating our user base a bit about the differences. Another thing is sometimes the date is confused with a publication date. Again, if people are used to a traditional library model and they think, oh, this publication, this magazine was published on a certain date, and I do a search, I should know my search date should match that publication date. Well, web pages really aren't published in the same fashion. Like that screenshot of the first Lucene page from Jakarta, there was no real publication. It just appeared one day, and it was there for a while, and then, boop, they changed it or it was gone. So communicating to people too, like what that date is. It was actually the date that we crawled the page, not when the page was published necessarily, if that makes sense. It's like the date that we saw it and we archived it. So again, it's kind of a challenge there just to get people to understand that. And then last, sort of this temporal diversity. You not only get multiple hits from a single website, you get multiple versions of the same URL through time. And in some cases, we can have hundreds of captures. That Lucene page I showed at the beginning, we had 122 captures of that page over 10 years. So again, imagine that dimension added to your search complexity. And here we go. So again, all these captures over years of time, when you do a keyword search, how should it work? How should people understand what it's doing? All those things. And then the last thing that makes life even more complicated for me is not only can you search in a particular collection, like in the case of the North Carolina collection I was showing earlier, you can actually search across sort of arbitrary groups of collections. For example, a single user might want to say, hey, I have 5 collections. I want to do a search against all 5 of these collections. Or just a regular person on the internet comes to archive.org, sees some cool stuff and says, yeah, I want to search. And they're not thinking, oh, is it this collection or that collection? They're just like, let me search everything and let me find some cool stuff. So although we manage our deployment and kind of organize everything by this one collection as one index, indexes can basically be combined together dynamically at runtime through, multi-index reader, that sort of thing. But there's, of course, a performance cost. So if anybody's ever had to deal with that before, they know what I'm talking about, where if you have a bunch of indexes on disk that are kind of separate collections and you're combining them together with a multi-reader, things kind of go in sequential order and it takes time. So that's a constant challenge. And the fact that we use a sharded situation where basically a shard is a collection and a collection is an index. It's distributed over 10 searchers, 10 searcher nodes. So we've had to build our own sort of system for distributing the search queries out and aggregating the results and doing all that stuff. So custom solutions, like I said, I joined the archive in 2008. 2008, 2009, we were actually using primarily a project called Nutch Wax, which was a bunch of modifications and extensions to the Nutch project. But over time, as we were not using Nutch for crawling because we have our own crawler that we've developed over the times, we started phasing out the bits of Nutch that existed. And then also Nutch said, hey man, why are we doing the search aspect anymore? There's this really cool project called Solar that's doing this really, really well. Let's let them do it. So we kind of got in this position where we said, okay, Nutch really isn't the future for us. At the time, there was enough questions about Solar we weren't sure of, especially when it came to the field collapsing feature, which I think then was still like a bunch of patches. So we just said, oh crap, we have to build our own kind of custom solution. So that's pretty much what consumed my life for January, February, March of 2010, was building a custom solution that really nailed exactly these features that we needed, dealing primarily with the field collapsing for the diversity, and then also time and combining collections together in a query efficient and quick manner. So what we have today, like I said, it's all on my GitHub. So if you go there on my thing, and I'll give you specific links in the next couple slides, but it's all there. It's entirely open. You guys can do whatever you want with it. It's Apache licensed. Go to town if you like it. Complain to me if you don't. We're investigating Solar. Some of the reasons why I come to these conferences, to see who's doing what and to hopefully meet and chat with people. But on the indexing side, what we built was this little project. And all my projects, I like to use little 3-letter names for them because I really like tab completion. So all my projects start with a different letter as well. But basically, there's this project called the JBs, which I named after James Brown's band from back in the day. And it basically is the code that we use for building our indexes for both Archive It and all of our other archival web collections that we have, which is like a whole nother beast. It's a bunch of code that can run in Hadoop or standalone. In Archive It's case, we actually are still running our indexing outside of Hadoop, just because we already have this infrastructure in place that's all script-based for managing the workflow. And so we're keeping an eye on things like Uzi and catalog and that kind of stuff, looking at how eventually we can get this all into Hadoop. But when we build one-off web archive collections for other partners, oftentimes we'll just do that in Hadoop because it's really fast and easy. But the Java code that I wrote that's in this project, the JBs, it's kind of like any index project you would write before Solr came along. You know, you take your documents, you open up a Lucene index, you shove them in, and you define the fields. So in that sense, the schema is kind of hard-coded, and it's designed around web documents, because web documents don't have a lot of metadata. Okay, there's a title and there's keywords, but it's usually just the contents of the page. It's not like a product catalog with 25 different fields of organized metadata. And in the process of doing this, we also do some link analysis, and we also take some curation information from our customers to help augment the scoring. So just using like in-link counts to help do boosts, and then other things where if a curator has chosen a website as part of their collection, then that will also give it a small boost as well. So when they're searching later on, they can find it near the top. So for index building, we have a custom solution, and for index serving or searching, we also have this custom solution. This one is TNH, which at the time was very cheekily named, called the new hotness, because we were trying to solve a performance problem. And unfortunately for my ego, the name kind of stuck, so now everyone's like, oh, how's the new hotness doing? It's like, oh no. But anyway, it's there. Like I said, it's all open source, it's free, anyone can do whatever they want with it. But again, it's like before Solr came along, if anybody wrote a custom Java search application as a web app, it looks exactly like that. You know, gets the HTTP request, looks at the parameters, creates a query, executes it, sends the results back. It also has a federated search component, which is what we use for our federated search area with the master slaves. And they all talk to each other over OpenSearch, because at the time it seemed like it was a really simple method of communication. And it also made it so partners of ours that use this code in their own organizations, OpenSearch was something that we could just point at and say, look, it's simple, there's documentation for it, it's public, you know, read it, it's not a custom proprietary protocol. But we're looking at using something like JSON or something else. We're kind of down on binary serialization protocols between, just because it's kind of, can be hard to diagnose and monitor those things sometimes. So having it as a text format is nice. I can just, you know, grab the link, put it in my browser, look at the result. Oh yeah, that's good, or oh, it's broken, or oh, 500, something like that. But this custom code also does the multiple collection combining. So on disk, we'll have, let's say, 100 or so Lucene indexes, one after another. All of our collections are numbered, sort of, you know, 1, 2, 3, 4, 5. So you just have subdirectories with each collection in each Lucene index, and then they can be combined together in arbitrary ways for actually running the search. And then the last piece, which is something people might be interested to look at, especially if they've dealt with the grouping contrib module in Lucene or the Solr implementation of field collapsing. The original piece of code that I wrote to deal with field collapsing for us is in a CollapsingCollector, which is here, and it extends Lucene, basically uses a field cache for the website. So we just suck that into memory, and then we can do quick and efficient in-memory collapsing by site, and then retain the top hits per site. And you can control that via URL parameters. So if somebody wanted to, they could say, give me the top 2 per site, or 3 or 4. Or if you set it to 0, then it turns off the collapsing altogether, and you just get a strict, you know, relevancy score sort. So my last slide, and I got about 10 minutes, and then I'm sure everyone wants to go to lunch. So I just wanted to give a plug for the fact that the Internet Archive is not the only organization in the world doing web archiving and providing full text search of those web archives. So these are just some other examples I wanted to share with the audience. The ones that are not Archive It are their own institutions. They're not ours. They have their own implementation. I don't want to imply that, you know, we're building their services for them, but I just wanted to highlight. I know the UK Web Archive uses a Solr-based solution. So if you go to their web archives and play with it, Everything there is based on Solr. I was actually just in London last week talking with those guys and working together on some projects. The U.S. National Archives has a Web Harvest, and then the Web Archive of Catalonia, PattyCat, is also available. So since we're in Barcelona, I thought it was especially good to mention that project. So that's it. We got about 10 minutes for questions, and then lunch, which I'm sure everyone is excited for. Yeah. So the question is about change detection and intelligence. So as a page changes over time, can we detect sort of how much and do something smart about it?
So rather than just an ad banner rotation?
Yeah. So, well, right now we're actually doing the sort of stupidest thing and the most simple, which is MD5 of the page. So for ad banners, typically that wouldn't change in the sense of the ad banner is usually embedded as either a link or an iframe. So if the text of the page hasn't changed, then an ad banner change won't affect it. It won't be seen as a thing. Yeah, so like, hit counters and that kind of thing can definitely give kind of a false sense of page change. We're looking at some different techniques. I think it'll just take time to kind of build one that kind of hits that sweet spot of enough change that people think it's important, but not having kind of false positives or false negatives. So yeah, we're looking into it now, but right now it's a very strict, basically MD5 of the page, hasn't changed at all. But it's still just the text. So some types of changes to the page that aren't text, you'll still get the same MD5. So some trivial changes will be seen as, oh, this isn't a change. Does that answer your question? Okay. Other questions? Yeah, how do we handle deduplication? Basically, as we're ingesting and processing the web pages before they go into the index, we are applying a deduplication there. And for this gentleman's question, we're looking at duplicates based on effectively the MD5 of the page. That works really, really well in Hadoop, I'll tell you that, man. Like when we do our big jobs in Hadoop and we load this data set in, Hadoop, if our key is the URL and that digest of the page, Hadoop sort merge, man, that figures out duplicates in an instant. So right now, the archive service is running outside of Hadoop, so we just kind of we're doing it still through Java, the same Hadoop code, but it's basically just running in a local Hadoop instance rather than in our cluster. But some of our other big collections that we index in sort of one-off jobs, yeah, we just load it all into Hadoop and say sort merge, and then in the reduce step, we'll get the key, which will be the URL and the hash, and then those multiple values, and we can just say, oh, well, we know these are all the same, so take the first one. That would also be a chance where we could apply maybe some intelligence to compare different versions together as well. If we just had the keys being the URL, then we could look at different versions and apply some intelligence, but we're not there yet, unfortunately.
Are you doing any sort of like analytics on rate of change, things like that? I mean, I would think that'd be an interesting graph. What's dead, what's alive,
Yeah, and we're just starting to get into that. And it's driven not so much by necessarily providing that data as part of the archive service as the first step, but I think we're now engaging in more research type activities along those lines. So we're taking large sets of archive web data, some from Archive-It, some from other projects, and applying these kind of analyses to them. And we're actually using Hadoop and Pig for a lot of these things. So for example, we might take and look at, okay, for a large collection of data, take every URL that has more than 10 captures over time and do an analysis of the rate of change over time. There's some researchers here in Europe that gave a presentation at a conference last year I attended in Vienna that were trying to come up with predictive models predicting when pages are likely to change in the future to help you design your crawl strategy. So if you're archiving the web, if you can come up with some predictive models of what things are likely to change or disappear, then you can improve your crawl strategies as well. Some other things we're looking at, which I think is interesting, is also the web graph analysis from some of these large collections. And not just web graph as, hey, this page links to this page, but web graph over time. So again, adding that time dimension to it. So in the WayBackMachine, if you play with it, what you'll notice is if you look at a page and you click a link, well, we might not have that link to page captured on the exact same day. It might be a few days later, a few weeks earlier. So you kind of get this temporal drift as you're clicking around. And so what we're also looking at doing is doing some analysis to come up with some statistics or measures of, okay, for this collection of documents, what's sort of the temporal drift measurement? As if you were to browse around, what's the likelihood you would retain within a certain number of days or weeks as you go around, that kind of thing. So So yeah, so we're kind of in this position where we have like some really awesome, cool, interesting data sets, and we're really trying to engage with like a broader research community as to what are some really cool things we could do. Because like I said, we're a small organization and we focus on sort of bits in and bits out, suck data in and make it accessible. And although we're building services to meet the needs of other small organizations, we're also in a position where we want to be partners in larger, more interesting research projects that say, okay, let's take our data and have your researchers, university students or somebody do some really cool research on it and make that publicly available and benefit. Yeah, a question about choosing sort of which version, I guess. Well, choosing which of the duplicates to keep and which to not. So in general, the model is a unique document is a unique document. And so keep recrawling it, then subsequent versions will just usually omit those and we'll just update the existing one with new dates. Does that answer your question? I'm sorry?
There is a copy of a Wikipedia page out there.
Mm-hmm.
So could you keep both the Wikipedia page and the copy?
Oh, like at two different URLs? Oh, okay, yeah. So in that case, yes, because we're not really trying to do, like mirrored websites and detecting that. Primarily because these websites are chosen by customers specifically. And so if they've chosen that website, man, we better crawl that thing. They'll be upset if they go in and it says, well, it was just a copy of something else, so we didn't crawl it. They say, no, we chose it, so we want you to crawl it. So although we do deduplicate the same URL within a site, if we find the same contents on two different sites, we will still have those in the index together because a human being chose those two sites, and they should be in the index. Yeah, good question. The question is about using link analysis to help infer a publication date, or at least some sense of, hey, this page was born around this time. Yeah, we haven't yet, but it's a really good idea. I'll take that back. There's been some about certain things like newspaper sites and that kind of thing. Those do have published or publication dates usually on them somewhere. So we've talked about trying to apply some intelligent scraping to do that, but I think as people have looked at Google's thing about searching and going back in time, it can sometimes be erroneous in humorous ways. So we're kind of delicate about that, but I like your idea. We should talk about that at lunch. Any other questions? Yeah.
It's somehow not really related to the Lucene stuff.
Yeah.
Do you also, when you harvest the old sites, convert them somehow, maybe because some very old style CSS or HTML is no longer compatible to newer browsers? Are you doing something like that, or is it just the plain original?
Yeah. So your question is basically this very key food fight-esque question in the digital preservation community, which is one of emulation versus migration. So the argument is, do you migrate your data as formats change over time? I mean, who there still has WordPerfect files? Exactly. But there's actually a lot of WordPerfect files on the net that we crawled back in 1996. So the question is, do you try to migrate data formats forward, or do you maybe provide emulation where you might say, like, I don't know if people are familiar with this project called MAME, where people take old arcade games from the 1980s and they emulate the hardware so you can run the original ROM, the code on your laptop. That would be like an emulation kind of situation. So right now, we've kind of haven't really taken a firm stance on that at the archive because there's been enough backwards compatibility of the common formats on the web that we're kind of able to punt that question down the road a little bit further. But it's a raging question in the digital preservation community because librarians, look at this as like, oh, it's not just the web from 5 years ago. National Library of France has been around for 500 years, and the National Library of Great Britain, BL, they have documents from thousands of years old. So it's like, hey, if these web archives are really going to be permanent members of our data collection of our library, we have to come up with a solution for this problem. But right now, there's not a single, it's a raging debate in the community. But it's a good point you bring up because it is very important.
You have a billion of documents, right?
Yes.
And as far as I know, the maximum number of documents in the Lucene index is about 2 billion. What are you going to do?
Hopefully they fix that before we get there. Well, yeah, also keep in mind that the way we've designed our system where we have a collection is a Lucene index, that billion documents is spread over 2,272 indexes. So the largest single index we have is 33 million documents. It's when you add them all together it becomes 1.3 billion. So in a single Lucene index, we've only hit a maximum of 33 million. But it's when you aggregate them all together is when you get the big number. In some other collections that we've done for some of our National Library partners, where for like the National Library of France, we've done web harvesting of the entire .fr domain for 5 years. I think the largest collection we had for them was about 500 million documents. So we haven't quite hit that billion in a single index yet. And even when we do, I'm sure we would have to use a sharded situation just because we don't have like one big enough machine that can really serve that large of an index, so we always have to use a multi-machine scenario. So we'd still be spreading the documents around, but it's a good point. It's out there, and I'm sure we'll hit it sooner or later. Other questions? What we are using for crawling. So the archive has developed a web crawler called Heritrix, and it's an open source, freely available, Apache licensed web crawler. And it's really aimed at being a web crawler for archiving. So it has features specifically developed for writing the data out in this format called WARC, W-A-R-C, which is an ISO standard format for web archives. And it has these other features. So it might be a web crawler that doesn't fit your needs or somebody else's needs, but it's really custom designed for web archiving. But it's open source and it's out there, and I know there's other people that have used it in the industry for other domains. I'm just not saying it's the end-all be-all of all crawlers, but it's the one that we've developed, and it's written in Java, and it's open source, and everyone's free to use it. All right, one last question, then maybe we get lunch.
Are you admissible as evidence?
Ooh, man. That's actually an awesome question, and it's an awesome question because it's entirely above my pay grade. But just to give you a brief answer, we do, as an archive and as a library, we certainly do have certain legal protections in the United States. And as a nonprofit, what we're doing is for the benefit of humanity and not as a profit-making enterprise. So that gives us some protection, certainly against copyright claims and that sort of stuff. We also do have a very established process that we've had reviewed by lawyers by which we receive claims, we evaluate, and then in some cases we will remove access to stuff. If somebody is a legal owner of web content and they say, look, man, you guys archived our stuff, we want it taken down, and they can make a credible claim, we have a process that will evaluate that claim and we'll take it down. We'll take the access away, we'll never delete anything, because presumably in the future it's still valid to be kept, but at least we're not violating someone's copyright by republishing their content anymore. We've just cached it, so to speak. But there are other claims where people want to use stuff in the Wayback Machine as evidence in a court case, and again, that's a whole other thing that I'm so happy I don't have to deal with, but we do actually have legal aids that work for us that deal with those issues. All right, lunch? Yeah, great, thank you all.